So in our previous example, right, we looked at the graphical representation for a function, and we looked at how we can graph a function on the coordinate plane. But I guess the bigger question right now is, if I give you a graph, how do you know that the graph represents a function, right? So the one way we can think about it is something called a vertical line test. So what is a vertical line test? A vertical line test essentially states the following: the graph of an equation represents a function if no vertical line intersects the graph in more than one point. So in other words, if I have a graph of an equation, if I draw a vertical line anywhere in the plane, right, that vertical line cannot touch the graph in more than one point. It has to if it touches the graph, it has to be in one and only one point, no more. So let's take examples. Let's see when would a graph represent a function. Okay, let's consider the following graph. All right, so this is my x-axis here. This is my y-axis. Would this graph be a graph of a function? And the answer is yes, right? Draw any vertical line. I mean, just think about your y-axis. It cuts the function in only one point. Draw a vertical line here, right? That also passes through the function in only one point. So this is going to be the graph function, because no matter where I draw my vertical line, it's going to cut the function in exactly one point. Okay, so let's look at this next example. Okay, so here's our axis, and let's look at this graph here. Would this graph represent a function? And obviously no. I mean, look at the y-axis, right? It's a vertical line, and it touches the function in three different points: over here, over here, and over here. And we said that for a graph to pass the vertical line test, it should touch, no matter what vertical line you draw, it should touch it in exactly one point. So this fails the vertical line test, and so then this graph is not the graph of a function. It does not represent a function.